So students, let us see the important concept of projectile motion along an inclined plane. Projectile motion along an inclined plane. So in the inclined plane, the projectile motion there are two cases. One case is up the plane. The other case is down the plane. So let us take the first case one of the plane. So here let us take an inclined plane which is making an angle beta with the horizontal in this way, and if a body is projected with a velocity u, making an angle alpha with the horizontal. So let us take this one horizontal. This is the of the plane projected motion on inclined plane. So in this case we are going to find out the time of flight and the range. That means if you project it in this way, it will be gone in this direction and reached some point B here. Let us see B here. So we are going to find the time of flight and the range somehow to B. So the time of flight, how can we find out the time of flight? So this one is so this object is how much angle it is with the plane, with the inclined plane. That means alpha minus, it will be alpha minus beta the angle. So on the inclined plane direction, let us take an x-axis in this direction and y-axis in this direction. So and also take the gravitation is working downwards in this direction g, and this the perpendicular, it is making an angle beta. So in this direction, the horizontal component of this g is g cos beta, and in this direction g sin beta. Acceleration is working. So let us take in x direction, the velocity of the particle ux is equal to u cos alpha minus beta, and ax is equal to minus g sin beta. And also in the vertical direction, in the y-axis, uy is equal to u sin alpha minus beta, and ay is equal to in this direction minus g cos beta, right? Now here you see in vertical direction, in y-axis direction, the displacement is 0. So that means what is in y-axis direction displacement? 0 sin sy is equal to, the formula is uyt plus of ayt square. So here you see how much sy is equal to 0 and uy is equal to u sin alpha minus beta into t plus of into ay means minus g cos beta t square, right? If you simplify this equation, the t value t is equal to 0 or t is equal to 2u sin alpha minus beta by g cos beta. This is the time of flight. So at a time t is equal to 0, this is at a point O, and displacement at t is equal to u sin alpha minus beta by g cos theta. This will be the time of flight. This is one time of flight, capital T is equal to 2u sin alpha minus beta by g cos beta. Okay, now let us go to find the range. Range means range in x-axis direction, range is equal to OB. To find OB, let us take this one as a right angle triangle. Let it be, this is some point C. OB is equal to you see cos beta is equal. So let us continue this video. In previous video we have discussed about the time of flight on inclined plane of the plane, and let us see the range in this video. Range R is equal to, let it be, it is OB, that is equal to OC by cos beta. So first of all, OC we have to find. OC is the horizontal displacement. OC is equal to in this direction the velocity is u cos alpha into and that time of flight is equal to 2u sin alpha minus beta by g cos beta sin alpha minus beta by g cos beta. So here u square by g cos beta into 2 sin alpha minus beta into cos alpha. But in trigonometry, the formula is 2 sin A cos B is equal to sin A plus B plus sin A minus B. So let us use this formula here. Then we will get a u square g cos beta into, this one is sin A plus B means 2 alpha minus beta plus sin A minus B means minus beta. So then it will be OC is equal to u square g cos beta into sin 2 alpha minus beta minus sin beta. This is the OC. But here you see the range R is equal to OB is equal to OC by cos beta. That means let it be u square by g cos square beta into sin 2 alpha minus beta minus sin beta. So this is the range for the situation of the plane. You see, it can be. So students, let us see the case 2. Here case 1, we have seen of the plane, inclined plane projected motion along the inclined plane, and we have found the time of flight and the range. But let us go to the second case, case 2, down the plane. Let us try and let us take an inclined plane in this way, and making an alpha beta with the horizontal, and if an object is projected in this direction u, and it is making an angle alpha with the horizontal, this will be the beta, then this angle, and the projectile goes in this direction, and you have to take here this upward perpendicular to the plane, and this is y-axis, and the downward direction is x-axis. Then by taking the horizontal and vertical projections in x-axis direction, y-axis direction, if you take ux is equal to u cos alpha plus beta, and here you take the g downward direction, it is working, and also the perpendicular, let it be, the angle is beta here, downward direction, this is g, gravitational acceleration, g cos beta, this one is in the opposite direction, g sin beta. So You see ux in x direction, the velocity ux is equal to u cos alpha plus beta, and ax is equal to x direction g sin beta, and in y direction uy is equal to u sin alpha plus beta, and ay is equal to in y direction minus g cos beta. So by using these values in the same way what we have done in the earlier video, if you did the time of flight time will be 2u sin alpha plus beta by g cos beta, and r is equal to u square g cos square beta into sin 2 alpha plus beta plus sin beta. So this will be the results can be proved easily by using these values in the way of previous proof. Thank you.